Hello. I want to make a program where I get 2 points and a length of a cable, and it plots the catenary curve between those 2 points. This is not as trivial as I thought. Okay, so let me just show you. I'm going to make the program live for me, not live for you. And let me start right here. This is the best place I found how to construct a catenary cable, specific length between 2 points. It's on Math Stack Exchange. There were a lot of places that said how to find. I've already done how to derive that it's a hyperbolic cosine, but then what are the coefficients on there, the parameters? And a lot of them say, well, make sure that the lowest point is on the y-axis. Or on the on the y-axis. I'm like, how do you do that if you don't actually know where the points are? So this one is the most generic solution, and it's not trivial, right? Because here is my basic function for a catenary cable. Y is a function of x, but I don't know a, I don't know b, that's another a, I don't know c. So there's a lot of things. But if I know these 2 points, x1, y1, x2, y2, that's fine. And I know the length, which is actually an integral. And this one's not too hard to set up. I've done a thing on path integrals before. If I remember, I'll put a link down below. Then you can start going to town. And it gets crazy. It's just crazy. It defines all these new variables like the average x. And right here, I'm not even sure, is that dx is x2 minus x1. So is this x2 minus x1 divided by the parentheses 2a or divided by 2 times a? I think it's parentheses 2a. So there's a whole bunch of stuff. So let's just scroll down here to the final thing. And I'm going to, let's just make this t graph equals graph. Hopefully I'll remember to include a link down below for plotting. And this is just going to be the x title is going to be equal to x. The y, because I'm plotting a trajectory really. The y title, and it could be in units of meters and stuff, but let's just leave that out. Y title is just y. And then I'm going to need f1 equals g dots. And color equals color dot red, let's say. And then f2 equals g curve. Color equals color dot blue. So the g dots, that's where I'm going to put my endpoints. So now let's just go down here and let's do this as p1. P1 equals vector. I'm going to pick a point. I'm going to pick point negative 0.2 in the x direction, 0.1 in the y direction, 0. And then P2 is vector, let's say 0.3, 0.020. I'm just making up stuff there. Okay. Now let's go ahead and plot those points. So f1.plot, it's going to be p1.x, p1.y. If you have a vector, you can do dot x is the x component, dot y is y component, and then I'll plot the other one, f1.plot p2.x, p2.y. This video might be a little bit long. I apologize. And it might not even run at all. Look at that. Okay, there you go. So there's my 2 points right there. And I want to draw a curve between those two. Oh, I need the other thing I need to pick is my length. So this goes from 0.2 to 0.3. So it should 0.5 is the distance across, but it's going to need to be longer than that. Let's say the length is going to be L equals 0.7. And I'm just assuming that that's long enough. If I don't, I'll get an error. You can make a check for this later. Let's see. Catenary plot. Let's save that. And I can make the size of things bigger and everything like that, but I don't really care. Okay, so now I'm going to go back over here and scroll down through all the derivation, which is super awesome. Oh, the other thing I have to do is I don't have hyperbolic cosine and hyperbolic sine built in to this version of Python. So I'm going to have to make these two functions. So let's make hyperbolic cosine of, let's just do it just like this. I'm just going to copy that before I forget. And go over here def cosh h z, and then let's just return. See, that doesn't look good. So return, it's going to be e to the z exponent z parentheses minus or plus exponent negative z parentheses divided by 2. And then I don't know if I need sinh. So let's say def sinh of z, and let's see, it's just going to be the same thing but minus. So just copy that, paste that, and put a minus. And let's just check print cosh of 0. I think that's right. And yeah, okay. So that looks like it's working. Now back over here, appendix A, appendix B. Here is wait. It had a list. C. Okay, so let's just calculate this stuff. I need dx, x bar, dy, y bar. So let's say dx is going to be p2.x minus p1.x. X bar, I call it xb, is going to be p2.x plus p1.x divided by 2. And then I can do the same thing for y. dy equals p2.y minus p1.y. And then y bar is p2.y plus p1.y. I did that backwards, I don't know why. Divided by 2. Okay, now what else do I need? L, that's true. Now I need this r. I need r is the square root of L squared minus dy squared. And again, I think this is all over. Let's just copy that. That way I can paste it in here, even though it's wrong. Okay, now let's say r equals L times the square root of, oh, I shouldn't have done that because it just looks stupid. L is the square root, no, the square root of L squared minus dy squared. L squared, get rid of that, minus dy squared. All of that divided by dx. That's what I assume right here. Because I don't think dx is in the radical, because it'd be dx squared, right? So I think that's right. Let's just print this and make sure things are working, because I put some weird characters in there. So print r. Let's just see if that does it. And run that. You know, you always want to kind of take a moment and run things in the middle to make sure you don't have an error. Okay, I think that's good. I think it said something, r greater than 0, greater than 1. It was. Okay. Now I need to find this a. Oh, what's big A? Big A, capital A. Oh, I need C too, don't I? Where's A? Oh, let A equal dx over 2a. A equals dx divided by 2 times A. I don't know what A is. And we're 2a. Okay, go back up here to A. A. Let's see, x bar over 2, a equals dx over 2a. Therefore, r, okay. I think I have to solve for a from this. And so that's where, let's see, yeah, Yeah, RA can be solved for, so this is a not easy equation. So let's just write that down up here as a comment. R equals, what was it? Let's see, R times A, let's do that. R times A equals sinh A. R times A equals sinh A. Now, this is a transcendental equation, so I'm going to solve this by, I know R, I'm going to change A. Do I have any parameters for A? Then I can find little a. Okay, well, let's just do this. Let's just do that. So I'm going to say A equals 0.01. I don't even know. dA equals 0.001. And now I'm going to say left is equal to R times A. Right is equal to sinh A. Now I'm going to say, and let's just print those out. Print left and right. Let's see what happens. That's the left side of the equation and the right side of the equation. Okay, so here I have the left is greater, right? See that? Than this. So what I'm going to do now is to say while left is greater than right, do the following. Number one, calculate left and right. Let's just copy that. And then left and right equal to. This is going to be not perfect, but I just want to get it mostly working. And then A equals A plus dA, right? So I'm calculating both sides of the equation, and I'm seeing if they're the same. And once they become not the same, then I know my value for A. And then so I'll say, let's say print, let's say A, after that, A equals A minus dA. So I want to go back one step, and let's print A. Let's see if this works. It might get into an infinite loop, but I'm going to take that chance. I'm going to save it. I've gotten into infinite loops before. Come on. Okay, it did it. Okay, so I got A. I don't need to print this stuff. I don't need P. I can turn that off. And this was just a guess, but I think that's going to be okay. Now back over here. Now I can say A equals dx over 2A. A equals dx divided by 2 times A. That's good. And then B, let's see down here, do I need B and C? So I got that, or I got that. Then, okay, right here. So I got A, and now B is this. So B is x bar. B is x bar minus, I have the worst memory sometimes. A inverse tangent, I don't have an inverse tangent function in there, so let's see. What was inverse tangent, hyperbolic tangent? It's this. So I got to define that. It's going to be 1/2 the natural log of 1 plus z over 1 minus z. Okay, def tan h. Is that tan h inverse? What was that? Yeah, inverse. I'll call it, of z. Tan he. And that's going to be 1/2, I already forgot it. 1/2 natural log of 1 plus z over 1 minus z. So it's going to be, so return 1/2 times 1 plus z, natural log of 1 plus z divided by 1 minus z. I think that works. And is that? I need one more parentheses. And I'm pretty sure in Python log is the natural log. So I'm pretty sure that's right. Okay, so we're back up here. B is x bar minus a inverse tangent dy over L. B equals x bar minus a times inverse tangent, tang he, minus, did I say minus? Okay, minus a times inverse tangent of dy over L. dy divided by L. Cool. Next, C is going to be y I. Okay, so I can put I 1 or 2. This doesn't really matter which one. I'm just picking one of the data points. I'm going to pick 1. So C equals yi minus cosh a cosh. So let's say C equals p1 dot y minus a times cosh x1 minus b divided by a. P1 dot x minus b, all of that in parentheses, divided by a. Oops. Close. Okay. Check. Yep. Or you could do it that way too. Okay. So now I've got all those parameters. Now, write the equation, imply Newton's iteration. I did that. That's a little bit different than the way I did it. That's fine. That's fine too. I think I can redo this and do this better. They did that better. Okay, that's it. Is that it? Oh yeah, so I got A, B, C. So, okay, so now I can make the plot. So now I'm going to say while, so I'm going to say x equals p1 dot x. While x is less than p2 dot x, I'm going to calculate y. So y is going to equal, if this works, I'm going to freak out because I make mistakes all the time. Let's just go up here to the form they had. A cosh equals a times cosh x minus b over a. So it's going to be x minus b divided by a, and all of that plus c. Plus c. So now I'm going to need to plot that point. So I can say f2 dot plot x, y, and now I'm going to increase x. X equals x plus dx. Oh, I need that x plus d dx, which I need another value of d dx. So say d dx equals 0.001. And there we go. If this works, oh my gosh. Okay, let's run it. Just the bold and the brave, right? Just go for it. Oh my gosh. Look at that. I cannot believe that this worked. There you go. Now let's just double check, right? What if I move this down a little bit? I think the length should be the same. Let's just change the length. How about that? I'm going to make the length shorter. Let's make this 0.65. Still works. Let's move this point F2 down a little bit. So it's at 0.02. Let's make that 0. Okay. Now, the one thing I did not put in here, like I said I should, there's two things. One, a better method for calculating the coefficient A. But mine seems to be working, right? That seems to be okay. Number two, a check to make sure that L is long enough. Because if I don't have L long enough, it's going to break. But I'm done. I don't want to break it anymore. So I'm going to save this, and I'll post a whole bunch of links to stuff down below. And you may be able to tell I'm using this for something else. Right. And thanks for this link right here, which was super awesome. Who wrote this? Posted by, asked by. Let's see, what does it say down here? Excellent. Excellent. Marty Cohen. Awesome. Good job. Okay, there you go. I have that code. This code is linked below. You can go edit it and change it and make it your own. And I'm going to use this for something cool later, but there you go. I'll talk to you guys later.